In this class, I'm going to solve this question taken from lens formula, that is under optics in physics, a topic in physics. Of course, it stems from the general topic of waves. Now, let's look at the question. The question says that an object is 20 cm from a converging lens. If the image formed is 80 cm from the object, find the focal length of the lens. Of course, you know that we have converging lens and the diverging lens. Now, we have the lens formula we use generally. Okay, now the solution to this question. Solution. We have that the object distance, we use U for object distance, is equal to 20 cm. Then the image distance, we use V. And we are told that the image distance is 80 cm from the object. Of course, we know that the object distance is the distance of the object from the lens. But image distance is distance of the image from the lens. But look at this question, which is funny. The question says that the image is 80 cm from the object. So in other words, for us to get the image distance, we have to be careful here. So image distance is here. Okay, given that image distance from object is equal to 80 cm. From the question, 80 cm. Therefore, our image distance from the lens is V will be equal to what? 80 cm. Our V will be equal to 80 cm minus 20 cm to give what? 60 cm. So be mindful of this. So this is our image distance, the actual image distance from that lens. But this is the image distance from the object, which is not the real image distance. So the real image distance, the image distance from the lens. Then the object distance from the lens. Okay. Now, we now have that from here, we have that the focal length. We are looking for the focal length. So using the equation, using lens formula, we say that 1 over F is equal to 1 over U plus 1 over V. So this is the general lens formula. F is the focal length we are looking for. U is the object distance. V is the image distance. Now, from this formula, we have another formula. From this formula, we generate for the focal length. For the focal length, which is F, we have that from here, we have that F is equal to, when you simplify this, we have a general formula for F. F is equal to UV all over V plus U. So from this we obtain this. So from this equation, if we make F subject formula, because we are looking for focal length, this is what you will have. You can equally substitute these values here and then use the LCM or simplified fraction and get your answer. But this is the other formula we use to find the focal length. From this one we have the object distance and image distance, which we obtain from here, making F subject formula from this equation. So simply we have that our F is equal to, our U is 20 times our V is 60 all over our V is 60 plus our U is what? 20. And that will give us 20 times 6. 2 times 6 is 12. Have 1200. 60 plus 20 is 8 over 80. That will give us 0 cancel what? 0. And of course, you simply have that here. If you use 4 here, 4 divided here, give what? 30. 4 divided here, have 2. Such that 2 divided 30, you have 15. So our F is equal to 15 centimeter. So this is our focal length, 15 cm. And for example, if they had asked us to find the power of the lens, do not forget that power of the lens here should be 100 over what? F. That is because F is in centimeter. But if F is in meter, the power of the lens is reciprocal of the what? The focal length. It should be 1 over what? F. The unit is diopters. Good. So you see, it's simple to solve this. Thank you so much for paying attention to this particular class. To enjoy more of mathematics and physics, you visit my YouTube channel at Joe Newton Online Class. Follow me on Facebook page, even TikTok. Like and share for others to enjoy physics and mathematics with us. I remain your tutor and friend here, Joe Newton Online Class. Thank you.